All right, we're going to be going into Module 3, pages 95 through 104 in this section. This section, we're going into inequalities. Again, we've talked about expressions, equations, and inequalities. In expressions, there is no sign. There's no equal sign, greater than, less than sign. An expression is just a mathematical sentence, and all you can do is simplify it. An equation has an equal sign. And when you solve an equation, you tend to get one solution that you can graph on a number line or a two-dimensional XY chart. Inequalities have an inequality sign, a greater than, less than, greater than or equal, less than or equal, and they tend to have an infinite number of solutions. And you can graph as well those infinite solutions on a number line or a two-dimensional chart. As we go into this section, we're going to be going into inequalities. And so they're very similar to two-step and one-step equations. A couple little nuance changes that you have to be aware of, and especially when you graph them, that you're not graphing a solution, you're graphing an infinite number of solutions. So let's take a look. Again, I'm opened up to page 95 in Module 3, be greater than, solving inequalities with inverse operations. Our learning goals are going to be to solve and graph one- and two-step inequalities, solve word problems leading to inequalities of the form px plus q is greater than r and px plus q is less than r. We want to be able to graph solution sets of inequalities and interpret the solutions in context. Again, a solution set is a set of values that are true for a given inequality. The key terms, an inequality, again, it's a comparison that has a greater than, less than, greater than or equal sign. We want to be able to solve an inequality, find a solution set, and then talk about properties of inequalities. So please take a look first at the warm-up on page 95 on 1 through 4 and create 4 number lines. And let's graph each inequality on a number line. You can do it at the very bottom of the page, or you can do it on a separate sheet of paper. I did mine on a separate sheet of paper just because I thought it would be easier overall, though some of them take a little longer to write out. So, graphing the inequality x greater than 5. Well, since 5 is what's in question, 5 is the number, so I'm going to find number 5 on my number line and circle it. Since x is only greater than it, the circle remains hollow, it's not filled in. And x is greater, this side is the larger or greater side. This side is less, the smaller is over here. And so if x is greater than 5, it is a hollow circle with a thickened line going that direction, going to the greater. So 5 is not a solution, but 5.1, 5.2, 6, 7, 8, 9, 10, 11, 1,000, a million, a billion, those are all solutions. There's an infinite number of solutions to this inequality. The solution is every number bigger than 5. Number 2, x greater than or equal. The line underneath that inequality sign means it can be equal to it. X greater than or equal to 2.5. Well, let's find 2.5 on our number line. So perfectly halfway between 2 and 3 is 2.5. So I'm going to create a circle, in this case above it. I often will do mine above the number line. And so there's 2.5. Well, x can be equal to it. So that it's going to be a solid circle. It's filled in. And since x is greater, it's covering all the numbers bigger than that. On the third one, x is less than 6.2. Again, I need to locate 6.2 on my number line. So somewhere between 6 and 7, I'll find 6.2. 6 and 2/10. It's going to be around there. And so I'm going to create my circle above 6.2. And x is all the numbers less than that. So any number smaller than 6.2 is part of the solution set. 6 is a solution, 5, 4, 3, 2, 1, 0. I didn't write them, but -1, -2, -3, -1,000, -1,000,000, those are all solutions. So every number smaller than 6.2 is part of the solution set. You might have noticed on this side of my page, I also did the XY graph, a two-dimensional graph. A number line is a one-dimensional graph. And the Cartesian coordinate, or the XY system, coordinate plane, is a two-dimensional. On x greater than 5, again, I'm going to find where x is 5. And in this case, I'll put a line. Since x doesn't equal 5, it's going to be a dashed line, because 5 is not part of the solution set. But everything bigger than that, 5, is. And so everything covered on this side of the plane, on this side, is part of the solution. Again, a dashed line goes with a hollow circle. We'll be going into graphing in several weeks. I'm just foreshadowing with this, just showing you the difference between a one-dimensional and two-dimensional, one-dimensional number line, two-dimensional number system, and how to display this data. On number 2, x is greater than or equal to 2.5. Well, my first move is on my x-axis. I want to find 2.5. So halfway between 2 and 3. And since x can be equal to it, it's a solid line. And then not only can x be equal to 2.5, it can be everything over here greater than 2.5. So this whole side of that line gets shaded. The solid line means it can be equal to it, and the shading means everything over here is part of the solution set. Number 3, x is less than 6.2. Well, I want to find 6.2 on my number line. So again, or on the x-axis. That's my y, that's my x, my y, my x. 6.2, 6 and 2/10, will be about here. And x is just less than it. It's not equal to it. Since it's not equal, it's a dashed line. And x is less than it, so that comes out this way. Everything over here is part of the solution set. So let's take a look at number 4. X less than or equal to 9. Well, my first move on my number line is to find number 9, and above I'm going to put a circle. X can be equal to 9. It's less than or equal. Since it's or equal, solid circle. Less than goes in a smaller direction down the number line. So 8, 7, 6, 5, 4, 3, 2, 1, 0 are all part of the solution. Again, are the negative numbers part of the solution? And yes, they are. Everything smaller than 9 and including 9 is a solution to this inequality. It's part of the solution set. On my two-dimensional, find 9. On my, where x equals 9, I'll draw, since it can be equal to it, I'm doing a solid line. And x can be equal to or smaller, so everything over here gets shaded. That's graphing inequalities in a one-dimensional or two-dimensional. That's really all there is to it, to the graphing portion. And again, you're going to find that inequalities are very similar to two-step equations. Again, the graphs, because it's not just a solution, it has an infinite number of solutions. That's a subtle difference. The other difference is in an equation, when you have to multiply or divide the variable by a negative, nothing changes. It's fine just to divide or multiply by a -4 or any other negative number. In an inequality on page 105, where you're going to find out that whenever you have to multiply or divide an inequality by a negative number, the inequality sign is going to change direction. So if it was facing this way and you multiplied by a negative, it's going to change direction. Or if it was facing this way, greater than or equal, and you multiply that variable by a positive or negative number, it's going to change direction. But for today's lesson, we're not going into multiplying by negatives, so you're going to find today that things are very similar to two-step equations. Let's take a look at page 96. Page 96 asks us to consider the equation 4x plus 9 equals 1. And then they show us on the number line that -2 is the solution to this equation. They want us to verify the solution is correct. And are there any other solutions to this equation? Explain your reasoning. Well, my first move, when I see an equation, I want to solve it for myself and verify and see if I get -2 as an answer. And so I took a look at 4x plus 9 equals 1. And I needed to get x all alone. I needed to isolate x. So x is being multiplied by a 4, and 9 is being added to that x. I decided to get rid of the positive 9. Get rid of a positive 9 by subtracting 9. And whatever I do to one side of the equal sign, I do to the other. And that's a property of equality when you have an equal sign there. So 9, take away 9, 0. 1, take away 9, -8. Or if I had 9 bad guys, 1 good guy, who's going to win the shootout? Bad guys. How many bad guys are going to be left standing? 8. Because these two signs are different. So 9 take away 1 is 8, and the bad guy's 1. 4 times my unknown is -8. Well, my unknown's being multiplied by a 4. How do you undo multiply? With division. Divide both sides by a 4. 4 divided by 4 is 1. So I have 1x. -8 divided by 4. Well, first I have to deal with signs. Negative divided by positive, negative. 8 divided by 4, 2. So -8 divided by 4, positive 4 is -2. So I get their -2 as the answer. So I like that. To verify that we have the right answer, the beauty of equations and equalities is you can test your answer and see if you have it right. You really don't need to wait for your work to be corrected. If you want to plug in the number, substitute it in, you can see if you have the right answer. So that's what I'm going to do here. I believe -2 is the right answer. So I'm going to substitute this -2 for x. 4 times x, but I said x was -2, plus 9, does that really equal 1? Positive times negative is negative. 4 times 2 is 8. This plus 9 comes straight down, equals this positive 1 comes straight down. 8 bad guys, 9 good guys. Well, again, if they had a shootout, my good guys are going to win. Signs are different. Find the difference. 9 take away 8, 1 equals 1. That's a true statement. So not only did we solve it, we checked our solution, so we feel very confident that we have the right answer. On number 2, on page 96, they give us a set of numbers. we don't know if these are a solution set. It's just a set of numbers at this point in time. They give us 7 numbers, a -5, -4, -3, -2, -1, 0, and a 1. And we're going to check each of these numbers to see if it really is a solution. Use substitution to determine which values are solutions to each inequality. Plot the solutions for each inequality on the given number line. So they gave us 4 times x, 4x plus 9 is greater than 1. 4x plus 9 is less than or equal to 1. Oh, well then, in this case, these solution sets are, I'm hoping you agree, 4x plus 9. If we put in a number and it's bigger than 1, it's part of this. If we put in one of these and it's equal to or less than 1, it will be part of this one. Each of these 7 numbers has to belong to this inequality will be a solution to this one, or they're going to be a solution to this one. So let's take a look at those as well and see what we get. So I have my solutions, my set of numbers, and now I'm just going to use substitution and see. So I'm going to let this number line be 4x plus 9 is greater than 1 for 2a, and 2b is going to be 4x plus 9 is less than or equal to 1. I'm going to solve this one or simplify and see if it creates a true statement. And so again, if one of these numbers, if -5 is not a solution to this inequality, then it will be a solution to this one. Because this covers all numbers on the number line. You're either bigger than 1 or equal to 1 or less than it. It would be like if somebody said, hey, I win if you pick a number greater than 1, but I also win if you pick 1 or any number smaller than 1. It's going to cover every number. So let's check -5. Let's see which of these inequalities -5 is a solution to. 4, I'm going to substitute in instead of x times -5 plus 9 greater than 1. 4 times -5. Positive times negative is negative. 4 times 5 is 20. Plus 9 is greater than 1. 20 bad guys had a shootout with 9 good guys. Bad guys win. 20 minus 9 is 11. Is that really greater than -1? Is -11 greater than 1? Excuse me. -11 greater than 1? It's not. That's a no. That's not true. So therefore, -5 is not a solution, part of the solution set over here. -5 is going to be part of the solution set over here. So I'm going to put it on this side, -5. Let's try the next one, -4. Let's see if -4 is part of the solution set. 4 times -4 plus 9, is that really greater than 1? Positive times negative, negative. 4 times 4, 16, plus that 9, greater than 1. 16 bad guys have a shootout with 9 good guys. Bad guys win. 16 take away 9 is 7, so 7 bad guys remain. And I end up with, is -7 bigger than +1? No, that's not true. So -4 is not a solution to this inequality. -4 is also part of the solution set over here. Well, so far we're 0 for 2 on this side. Let's switch over. We'll try this one and see if -3 works on this side. 4 times x, but we said x is -3, plus 9, less than or equal to 1. 4 times -3, positive times negative is negative. 4 times 3 is 12, plus 9 less than 1. 12 bad guys have a shootout with 9 good guys. Bad guys are going to win. 12 take away 9 is 3, less than or equal to 1. Is negative 3 less than or equal to 1? That's true. So negative 3 is a solution on this side. Let's try negative 2. We'll try it over here on this side. It worked actually, I guess it's worked the last 3 times. 4 times negative 2 plus 9, is that really less than or equal to 1? Positive times negative, 4 times 2 plus 9, less than or equal to 1. 8 bad guys, 9 good guys have a shootout. Good guys win. 9 minus 8 is 1. Is 1 less than or equal to 1? That's true. 1 is equal to 1. So negative 2 is a solution on this side. Let's take a look at negative 1. I'll come back over to this side. 4 times negative 1 plus 9, is that really greater than 1? Positive times negative is negative. 4 times 1 is 4. Plus 9, is that going to end up being greater than 1? 4 bad guys, 9 good guys. Good guys win. 9 minus 4 is 5. 5 is greater than 1. That's true. So negative 1 is a solution over on this side. Let's try the next one is a 0. 4 times 0 plus 9, is that going to be greater than 1? 4 times 0, 0, plus 9 greater than 1. 9 greater than 1, that's true. So 0 is a solution to this side. And let's do this final one. Let's put a positive 1 in. 4 times positive 1, I'm going to do it on this side, so we'll see what we get over here, is less than 1. 4 times 1 is 4, plus 9, less than or equal to 1. 4 plus 9 is 13. Is 13 less than or equal to 1? No, that's not true. So positive 1 has to be a solution on this side. And it looks like I'm going in that direction to where everything going this, I would speculate everything negative 1 and bigger is a solution set over here. And everything negative 2 and smaller is a solution over here. Let's take a look. (4x plus 9 greater than 1). Let's simplify that. Let's solve it like a two-step equation. So 4x plus 9, let's subtract a 9 from both sides. And when I do that, I get 4 times x greater than negative 8. Divide both sides by 4, and I get x greater than negative 2. So let's find negative 2 on a number line. Circle. X is greater than it, so it's a hollow circle. So every number bigger than negative 2 is part of a solution to this one. All numbers greater than negative 2 are solutions. Well, 4x plus 9 less than or equal to 1. Let's subtract a 9 from both sides. And I get 4x less than or equal to negative 8. Divide both sides by a positive 4. X less than or equal to negative 2. And so over here, I find my negative 2 on my number line. X can be equal to it. It's less than or equal, so it's a solid circle. And every number smaller is part of the solution. So if it's negative 2 or smaller, it's a solution, part of the solution set to this side. All numbers less than or equal to negative 2 are solutions. So again, we have all numbers because this one has every number bigger than negative 2, and this one has negative 2 and all the numbers smaller than it. Page 97. In this lesson, you'll learn to solve an inequality. To solve an inequality means to determine the values of the variable that make the inequality true. The objective when solving an inequality is similar to the objective for solving an equation. You want to isolate the variable on one side of the inequality symbol by using the operations of addition, subtraction, multiplication, and division. Let's investigate what happens when each side of an inequality is added or subtracted by the same number. Consider the relationship between the two numbers 3 and 6. Since 3 is to the left of 6, that means 3 is less than 6. Perform each operation of the numbers 3 and 6, then plot the new values on the number line. Finally, write a corresponding inequality statement. So, we're adding a half to each. This is pretty friendly. They give us, again, no surprise, 3 is less than 6. On a number line, I can put my 3 and my 6 so you can see them visually, that 3 is over here on the smaller side. Everything over here, they get bigger as they go. The space between is 3. 4, 5, 6, there's 3 number interval between. On 1A, they ask us to add a half to each side. 3 plus a half is 3 and a half. 6 plus a half is 6 and a half. Let's graph it. 3 and a half, 6 and a half. The inequality sign remained the same. And the interval between remained unchanged. Add a 2 to both sides. 3 plus 2 is 5. 6 plus 2 is 8. 8 is bigger than 5. Let's put them on our number line. And the interval is still 3 numbers. That didn't change either. The inequality sign stayed the same, and the direction of the inequality sign stayed the same, and the spacing, the distance between the two numbers, remained unchanged. When you add or subtract the same number to both sides of an equality, the inequality sign remains unchanged, or the inequality sign doesn't change. From this point, I'd like you to be able to finish pages 97 and work your way all the way up to page 104. And on Wednesday, I'll set up page 105 through 109, or after 2 days. I'll set up pages 105 to 114, in the second half, where we start multiplying and dividing by negative numbers attached to the variable. So good luck on that, and I will post the answers to these questions, but just do your best on and see what you come up with.